Hello everyone. In this video we'll learn how to the mean value theorem. The mean value theorem basically says if there is a function f that is continuous over the closed interval and differentiable over the open interval, then for sure there will be at least one number c belongs to this interval in which the derivative of the tangent at that point would be equal fb minus fa over b minus a. By looking at this graph here, the function here, this is fx. It's continuous over the interval from a to b and differentiable. Now, if I match between these 2 points, we are going to have a secant line. The slope of the secant line, we can find it, which is fb minus fa over b minus a, right? Now, the theorem says there will be a number, let's say it's c, between a and b, in which if I want to take the slope, I'll draw the tangent. At that number c, this line and this line will be parallel, so their slope is going to be equal.
Let's look at this example. Find the values of c that satisfy the mean value theorem for the function fx over the interval, a closed interval, -1 to 2. Now when it comes to c, you might find c a number between -1 to 2, which is like something like 0 maybe, or 1. A number, one of the boundaries, so it could be -1 or 2. Or something outside the interval, something like c equal 3. Now what happened? When it comes to a number inside the interval, you can say c belongs to the interval -1 to 2. So c is equal 0 will satisfy the mean value theorem. What about if it is a number outside the interval, does not belong to the interval? So you will say c equal 3 does not belong to the open interval -1 to 2. Therefore, c equal 3 does not satisfy the mean value theorem for fx over the interval -1 to 2. What about if c is -1 or 2? Well, it's the same. It does not belong to the open interval -1 and 2. Therefore, c equal -1 does not satisfy the mean value theorem. The only case where c will satisfy the mean value theorem only if I found a number within the open interval. Okay, so let's look at this question here. We need to find the c's. So first of all, based on the theorem, you will find f prime of c, which is equal fb minus fa over b minus a. In this case, this is a and this is b. So you're going to say f2 minus f -1 over 2 minus -1. Now, what is f2? f2 equal -2 times 2 cubed plus 3 times 2 squared, which is equal -4. f -1 equal -2 times -1 cubed plus 3 times -1 squared, which is equal to 5. So you will come here and say it's equal to 5 minus will be -4 minus 5 over 3, and that's equal to -3. That's the first part. Now we need to find the derivative of x, which is equal -6x squared plus 6x. And now f prime of c equal -6c squared instead of x squared plus 6c. And now you want to equalize these two, so that's going to be -6c squared plus 6c equal -3. You will solve this quadratic equation. C will be about 1.4, and the second c is -0.4. Okay, so we need to study whether C belongs to the open interval here. It does belong to -1 and 2. It belongs to -1 and 2. Therefore, I have two values of C that satisfies the mean value theorem. C equal 1.4 and C equal -0.4. Now to find the exact value, we'll say if 1.4 equal -2 1.4 cubed plus 3 times 1.4 squared, and that's basically about 0.39. If -0.4, when you substitute it, you will get also about 0.61. So the values are 1.4 and 0.39 and -0.4 and 0.61. Let's look at this question here. When I have piecewise function, we are going to follow the same step. This is going to be, the interval is basically from -4 all the way to 5. So I'm going to say f prime of C equal fb, which is f5, minus fa, which is -4, over 5 minus -4. f5, we are going to substitute 5 here. We will substitute -4 here. So f5 will be equal to 2 times 5 squared minus 3 times 5 plus 1, which is equal 36. -4, -4 squared minus 5 times -4, which is equal also 36. So now you're going to say here equal 36 minus 36 over 9, that's equal to 0. Now you will find the derivative. So f prime of x, which is equal to 2x minus 5, and here 4x minus 3. You will make each one of them equal to 0. And you will solve it. So first you will say 2x minus 5 equal to 0, x equal 5 over 2. Second one will be 4x minus 3 equal to 0. And we make it equal to 0 because of this number here. So x equal 3 over 4. Now you need to study whether, and that's going to be basically C. Okay, so that's going to be C. So now we need to study whether this C belongs to the open interval. So first part, we need to study it on the first interval, subdomain. 5 over 2 does not belong to -4 and -1. So this C does not satisfy the mean value theorem. Where when it comes to the second one here, 3 over 4, this one belongs to the subdomain -1 and 5. So I have only one C that satisfies the mean value theorem. I need to find FC, which is by substituting in this equation. So F 3 over 4, 2 times 3 over 4 squared, minus 3 over 4, plus 1, which is equal to -1 over 8. So now I do have one C that satisfies the mean value theorem, which is 3 over 4 and -1 over 8. Now in this question, fx, x squared minus x, where x in between 0 and 1, and 2x squared minus 3x minus 3 if x in between 1 and 2. And first of all, we need to find f prime of C, which is equal the first and last points here, f2 minus f0 over 2 minus 0. Now when it comes to f2, we're going to substitute in this function, and by substituting x by 2, it's going to be 2 squared and this is going to be 2, the answer will be 11. And if you substitute f0 in this function, it would be 0 squared minus 0, and that's going to be 0. So we can say it's equal to 11 minus 0 over 2, and that's going to be 11 over 2. So that's the first part. Now we are gonna differentiate fx. So f prime of x will be equal to, and basically we are gonna call it c instead. So it's f prime of c. Instead of x, I'm gonna use c. So that will be 2x 2c minus the derivative of x is 1. And here it will be 4c plus 3. And I'm going to make each one of them equal to 11 over 2. Now by solving the equations, we are going to get, for the first one, two c equal 11 over 2 plus 1, 13 over 4. For this one, 4c equal 11 over 2 minus 3, so c will be equal to 5 over 8. Now we need to study whether each one of these belongs to the intervals. So this one does not belong to the open interval 0 to 1. This one also does not belong to the interval 1 to 2. So what does that mean? No value of c that satisfies the mean value theorem. In this question here, we need to find the values a, b, and m in which the function is satisfies the mean value theorem from 0 to 4, not to 2. So by mistake, sorry, that's 4. So let's try to think about this question. What does it mean, satisfy the mean value theorem? It means that the function is continuous and it's differentiable. Continuous means from the 0 side, limit as x approaches 0 from the right side should equal to f0. Same here, limit as x approach from the left side equal f4. Now at 3, it has to be from the right side and left side. Limit as x approach 3 from the right side should equal to the limit as x approach 3 from the left side, and that's going to be equal to f3 as well. So we are going to use these to find the missing numbers. So now I'm going to say, what about the limit as x approach 0 from the right side? We are using this function here because that's from the right. So it's going to be negative x squared plus 2x plus a, and that's going to be equal to f0. Let's substitute negative 0 squared. f0 is negative 2. So a equal negative 2. So I found a. Next, I'll try from the 4 side. So limit as x approach 4 from the left side. I'm using this. And it equal to f4. f4 is also, we are going to use this one. So it's going to be 4m plus b equal 4m plus b. This is not going to help us. Okay, so we are not going to use it. So I'm not going to use that. So let me just write a equal negative 2. Turn this 4. Okay, so what we are going to use, we are going to try the 3 sides. So limit as x approach 3 from the right side. From the right side, we are using this function here. Limit as x approach 3 from the left side. And then we substitute. Negative 3 squared instead of a, I'm going to use the number I found, which is negative 2. So that's going to be equal to negative 5. So I could say, yeah. Now next, what about because if it is satisfies the mean value theorem, then it has to be differentiable. So let's try to find the derivative. The derivative of negative 2 is 0. The derivative of this function is going to be negative 2x plus 2. The derivative of this is going to be m. Now if I try to find again the limit from the right side and left side of 3 now for the derivative, I'm going to say limit as x approach 3 from the right side, I'm using m, should equal to the limit as x approach 3 from the left side, and that's going to be negative 2x plus 2. So m equal negative 2 by 3 plus 2, and m will be equal negative 4. Since m equal negative 4, I can go to this equation here and substitute m by negative 4. So b will be equal to 7. And here we go. Last question. What about the same idea? What we are going to do, we'll follow the same steps to find a, b, and c. So we're going to do the limit as x approach 0 from the right side. We're using ax plus b equal to f0. Now a by 0 plus b equal f0 is 1, so b equal 1. Now the limit as x approach 1 from the right side, which is x squared plus 4x plus c, will be equal to the limit as x approach 1 from the left side, ax plus b. Now substitute and instead of b I'm going to use 1. And c will be equal a minus 4. Then we will take the derivative. So the derivative of f zero a 2x plus 4. Limit as x approach 1 from the right side equal limit as x approach 1 from the left side, which is equal to a. Now 2 times 1 plus 4 equal a, and then 6 equal a equals 6. You can go here, substitute a by 6. So by doing that, a is 6, b is 1, and c is 2. So that's everything about the mean value theorem. Please let me know if you have any question, and see you in the next video. Bye bye.